Hi everyone, I'm Nikhil Gupta. I'm an ML engineer at TensorWave, and I'm going to be discussing a couple customer case studies to demonstrate how far we can push the frontier of AI compute. So first, what is TensorWave? We are an AMD-only neocloud, so we provide access to state-of-the-art AMD GPUs running in Supermicro servers. Going AMD only raised some eyebrows when the company was founded about 2 years ago, but the reasoning was solid. We wanted to break the CUDA moat and the NVIDIA monopoly by making AMD a viable choice in the AI market. Since then, there have been significant improvements across software and the hardware, and more companies are taking AMD very seriously. Just take a look at the big OpenAI deal that was recently announced. News like that lets us know that we're on the right path, and we're happy to be working very closely with Supermicro to plan and deploy our data centers, with the first two in Tucson and Miami. So these data centers have air-cooled MI300s, which were the first ones we spun up, and then we moved to direct liquid cooling for the MI325s and MI355s. We deployed the largest direct liquid cooled MI325 cluster, and it's fully networked for large-scale inference and training. And we were also the first to deploy the MI355 GPUs with the new Pollara AI NICs. Supermicro has been a fantastic partner throughout all of these initiatives, and we're very excited for our future data center buildouts with the 355s and the rack scale MI400 GPUs. I actually got a chance to visit our Tucson data center recently and, see the racks, and the DLC makes it much nicer to visit. There's no noise, no loud fans, it's a very comfortable temperature, and it allows us to scale up a lot bigger, a lot faster. So a bit more background on TensorWave. Our founders, Jeff, Derek, and Peter, bring extensive experience across the board, from marketing to operations to infrastructure. We're one of the largest tech startups in Nevada, and this year we raised a $100 million Series A, which was the largest in Nevada startup history. We're growing extremely rapidly, so it's a very exciting environment to be in. So on to the customer case studies. First, I'll discuss inference on AMD with Modular. So Modular is building out a unified compute layer for AI. It has three parts: Mojo, which is their GPU programming language; Max, which is their optimized inference engine; and Mammoth, which is a cloud orchestration layer. We at TensorWave have partnered with Modular to support the development of this ecosystem, since we have a shared vision of optionality for end users. Thanks to optimizations from the Modular team and the higher GPU memory capacity of AMD GPUs and the TensorWave Supermicro infrastructure, Modular has been able to show significant enterprise benefits: almost 2 times greater inference throughput, and 40 to 60% cost reduction on the MI355s when using Max. These can be workload specific, but we have published blog posts on our website that detail the performance improvements across a variety of workloads. Next, I'd like to discuss an example of training on AMD. We've worked with an established telecom company to utilize ScalarLM. So ScalarLM is a project that is supported by TensorWave and developed by Greg Diamos and his team. If you don't know who Greg is, he worked on architecting CUDA, he co-founded Lamini and MLPerf, and is now developing ScalarLM. So ScalarLM is a project unifying the inference and training pipeline. It creates a seamless framework for serving model inference, training and fine-tuning those models, and then updating the inference server with new model weights without ever having to leave the framework. This enables really rapid deployment and improvement of models and scaling up of these pipelines. Additionally, ScalarLM is entirely open source and built on open source projects such as VLLM and Megatron, which aligns strongly with TensorWave and AMD's commitments to open source software. So coming back to this particular use case, this company has an internal LLM tool for various business units, as many companies do now. For some metrics, they run more than 9 billion tokens a day with nearly a billion API calls. In addition to this current internal iteration, they plan to make this tool customer-facing, dramatically increasing the amount of traffic it will handle. This is a perfect case for a fine-tuned, self-hosted model. Rather than sending API calls to services like ChatGPT and Claude, data can be set secure and internal. Additionally, with fine-tuning, a much smaller model can be used, which makes the tool much more efficient and scalable. Imagine running a model with the performance of Llama 405B, but with 1/100th of the footprint. This would mean that instead of using one node of MI355s to run one instance of Llama 405B, you could actually run 64 instances of this model on a single node when you use GPU partitioning. Additionally, since the model is much smaller, it can run much faster, dramatically increasing throughput. Knowing these things, this company fine-tuned a 4B version of Gemma on specific telecom data. As you can see in these images, the fine-tuned 4B model, which was built from Gemma, topped the telecom benchmarks, outperforming top models such as GPT-5, Sonnet, Grok, and GPT-OSS. It also topped the Spider 2.0 leaderboard for SQL benchmarks. Clearly, tiny models can be highly effective when properly fine-tuned for a specific use case. Thanks to the TensorWave infrastructure and the ScalarLM platform, this company was able to rapidly iterate and test a variety of training configurations to arrive at these results in only a matter of a couple of weeks. We're excited to continue supporting this project as they scale up to training on larger clusters with even more data, and we're excited to see the results of these training experiments presented at GSMA 2026. The combination of state-of-the-art supermicro hardware, TensorWave infrastructure, and software advancements across the board from the likes of AMD, Modular, and ScalarLM, we're truly pushing the frontier of what's possible with machine learning and AI. TensorWave is committed to continue this wave of progress and commoditize compute in order to drive further progress and innovation. Thank you for listening.